quickly.
2 sine theta times
Cosine theta.
theta.
There's, you gotta have that to work with. I'll come back to it to answer that question. Cosine double theta, just a little reminder, I think I started out with, guys, do not let me write this down wrong, cosine squared theta minus sine squared theta. Yes or no? Is that one version of the cosine double theta formula? Please tell me.
Yeah.
Okay? Now you can play around with this, and I think another version was, the 4 o'clock session today saw this. Another version of that formula, if you'd like to use it, is that. And another version, and I think I went through all these different versions last week with you, was that. So this one has, you have a choice. You've got 3 that you can turn to, but you gotta know your formulas. Tangent, I did not give you. I didn't give you a formula for tan double theta. The textbook has, but I think you have enough to memorize as it is. When I finally reached this last one here, and asked you to find tangent, I did not give you a formula. Someone be clever and tell me how could you find the answer?
Right there as a reciprocal.
As what now? 2 more.
2 sine.
Nuh-uh.
Sine.
Sine double theta.
Sine double theta over cosine.
There you go. That's all I need. That's all I need. Take the sine or cosine, double theta, and therefore need not use or come up with another formula. Okay, guys, now I gotta find the answer here though. Let's go back, sine double theta with that formula, and it all relies on this formula. The formula says you can find it if you have sine theta and cosine theta, just put them in, multiply by 2, and you got the answer. They didn't give me sine theta. They didn't give me cosine theta. Now, can someone tell me on the side here, what should I do? They did not give me this that I need for the formula, they gave me this. So they're trying to make a student think, I think, to go through this. Okay, Samantha, go for it.
You can use identities.
You can use identities, and we use the smooth marker. Now, they give me tan. Guys, in your mind, you're about to think, okay, professor, you mean sine squared plus cosine squared is equal to 1. 1 plus tan squared is equal to secant squared. What should I use, professor? Samantha, do you have one in mind?
Yeah, I believe it is 1 plus, is it tan squared theta equals secant squared theta?
Beautiful. She says, professor, I'm gonna start with that one. There's more that you gotta know. You gotta know your identities. Now they gave me tan to be what, 4/3? So I'm gonna put that 4/3 into her identity here. Got squared. It's equal to secant squared. We're gonna have 1 plus 16 over 9, looks like. Add that up, guys, I think with the common denominator of 9, I think it's 25 over 9.
Yes.
Equals secant squared. And you know, now do a square root. At this point, that would be plus minus is perfect, it's 5/3. Now, it cannot be both. So that's why they told you where this angle is located. The angle we're talking about is located between pi and 3 pi over 2. There you go, exactly.
Negative.
You're down here. Aiden told me the location here. He says, Professor, tell me you're down in quadrant 3. And quadrant 3 down there, I'm looking for a secant. Is secant negative? X is negative, so 1 over x would be negative. So I'm going to accept the negative 5/3 as the secant value. Samantha, I love what you did there, but back to here. Here's what I'm trying to find in the black.
Just do secant.
I don't have it yet. I need either sine or cosine. I've got secant. Now what are you going to do?
Just do the inverse of secant.
Absolutely. We'll quickly say, wait, professor. Secant is equal to 1 over cosine. In other words, they are reciprocals. So knowing that, guys, right quickly, we can say cosine is secant just flipped over a negative 3/5. Now that goes right here, finally. I got that much. This is a problem that would take probably a half sheet of paper to do. Now, the other part missing for me to finish up, answer the question, is sine. So how are you going to find sine?
Is the other identity?
Like what?
Sine
sine squared, and plus cosine squared
Yes, was one.
equals one. There's all these identities. I'm gonna put in the negative 3/5, guys, that we know at this point. It's about a long drawn out problem. Negative 3/5 n squared is equal to one. Clean this up, you're going to end up with sine squared. Looks like plus 9/25. Do my math here. Hope we don't make a mistake here. Move that 9/25 over, use a common denominator. I'm looking at myself. I think you end up with 16/25. You guys who are on it, I think it is 16/25. Take a square root, thinking this is perfect. This time it's 4 what, over 5? That's plus minus, so I'm going to decide which one. This is actually a square root.
Negative.
Now, yeah, I'm down in quadrant 3, and sine is negative, so that's going to be a negative 4/5, because I'm in quadrant 3. Going back, look at this, how much work it's taken here. Now you know what this is. Negative 4/5. And of course, you got the 2 out front in the formula. Now, if you multiply all that together, guys, I think, help me out, it's going to be a positive answer. Is it 24/25? You multiply all this out? I think.
Yeah, 24 over 25.
There's your answer. You're done. Part. I'm not going to do the rest of this. They know how to do this, but do me a favor, right quickly. Would you find out what tan theta, or what is theta? They give me tan to be 4/3. Could you do an inverse tan on 4/3 and see what that may show? It may not show what I want, but see what it shows. Just out of curiosity.
53.
How much?
53.
Okay, 53. Now we're down in quadrant 3, so add 180 to it. Add 180 to it. That'll move it down to quadrant 3 where we are.
233.
233.
Yes.
Okay, now, so that's theta. Now would you double it? Look at all this work.
466.
Now take sine of it.
Sine 466. Okay.
And see what find the sine of that double angle is.
0.96.
0.96?
Yeah.
Now, we got this. We got 24/25. Now let's take 24 divided by 25 and see if that's close to 0.96.
Exactly 96.
So we did not have to use any device at all. So when I create this test, which has already been created for you, constructed for you, I gotta be careful what I put in there so you can deal with it. Okay? And that's the answer. Now, how are you gonna do this? You're gonna do the same thing. Use one of these versions. Go over here, pick up your values, put them in, and crunch out. A tan, sine over cosine, Lisa. You take my sine answer that I worked out for you, put it over the cosine answer, and you get tan. If I ask for secant, you'd be what? 1 over cosine, reciprocal. Okay, so watch out for that. So that's a good little recap type problem there. Now, before I leave all this recap, I did do this for us. I sure did. Right here, part B. Says to establish. Now, I brought this one in. I hope it doesn't take too much time here. Secant theta times sine theta. I'll do just a brief one. Now, what they want us to do, they use the word establish. They don't want you to solve it. They want you to be clever with identities and show those two sides are really the same. Now, can anyone tell me, maybe on the left-hand side, what I might do? It says secant theta times sine theta should be equivalent to tan theta. Don't try to solve it. Does anyone see anything on the left-hand side that you may rewrite and might lead me to where I want to go? Sarah?
1 over cosine.
Right here, this is 1 over cosine.
Sine over cosine.
There you go. And this is sine over cosine. Now I gotta step back and see if I had this.
How does that sine over
No,
two?
like, it, like.
That's sine over 1.
Yeah.
Sine over 1.
Sine over 1, but then
Right, we're gonna
Add
put this
together.
together now.
Becomes
With a
sine.
common denominator, what, cosine?
You just multiply.
We're gonna end up what, sine over cosine, just sine over cosine. And guys, is that sine over cosine going to give me what I'm looking for? I'm keep on looking over there. Is a tangent. With that one replacement she gave me. Is that true? That's done. Now, that's a sample. This, I'm gonna show you one that may require a little bit more, but it's the same process. I'm not gonna do it for you. You can practice with it. I brought this one in. And we got the easier one out of the way here. Here we go. This one's not too bad. I'll leave this up to you. Part C, you got this. Sine theta plus cosine theta squared. And you're going to add to it sine theta minus cosine theta squared. And you're trying to show that's equal to 2. Let me make sure everything's copied down correctly there. And it is. Now, I'm not going to do that one for you. Think about it, try it. And what you're going to do, David, is probably look on the left-hand side, start playing around with it. And they're saying if you play around with it and use some identity somewhere maybe, you can show all down the left-hand side is equivalent to 2. Now, I'm not going to do it right now. I'm moving on. But you see what's going on here. Okay, so you guys can try that for a little practice here. Now, that's part A, part B, me trying to recap all this, part C. Last thing I'm gonna do, part recap. Oh, here we go. Find the exact value of this. Let me just do this, guys. Cosine, double, inverse sine, 3/5. Nice. Okay. Now I'm gonna work this one out. Here's the now. Let me give you a hint. If this were missing, and you look back through your notes from last week, this looks much like maybe a problem I had done earlier in setting this up. But they placed this time a 2 there. Can anyone give me a hint on what on earth would you do? I have a couple of these on the test. Now, I don't want you to come in during winter. Winter class is full. Can't take any more students. What would you do?
Divided by 2?
No, I knew you were gonna say that, you can't do that. And at least if that 2 were out front, maybe divide by 2 and do something. In fact, I want to have it another side. There's no other side here. They're asking you to simplify that. It's equal to what? Marco, give me a suggestion real quick.
Would
So
we do
two-
one of the identities?
There might be an identity involved here shortly. You might say, Professor, I sure think I know what that means.
Sine theta?
Yeah, it means sine of some angle, theta, is equal to what? 3/5. And Marco, you were asking during that 4 o'clock session. Inverse sine has a restriction that theta must fall between what? Bracket negative pi/2 up to a positive pi/2. That's quadrant 1, quadrant 4 from last week. So at least you can do that for a little partial credit. You don't have the answer yet. So Sarah, I know all this right here circled is representing some angle, theta. Now what? They want cosine double that angle. How you gonna find it? It's a method.
Can you do a double
You're going to use the double angle formula. You're going to go back to cosine double theta, which has 3 versions. I don't care which one you try to use, and see if it'll work out for you, and apply a double angle formula. So down here, like Samantha told me here, back here, guys, if you want to try the first one, I'll try the first one. Cosine squared minus sine squared. I can try it. Here we go. Let me put this in black. And cosine squared theta minus sine squared theta. Now, we looked at here. Do we know what sine is right now?
Yes.
Yeah, sine is 3/5, so I can put that in. We've got cosine squared minus 3/5 here squared. Only missing is cosine. If I knew what cosine was, I'd put it in here, square it, subtract, and I got the answer. Does anyone have an idea how to come up with cosine? Cosine's not up here.
Identity.
Okay, tell me again.
Identity.
Identity, and what identity might be nice with what you see up here, the way we're breaking this thing down, might be used.
Sine squared.
Sine squared plus cosine squared. Absolutely. And then I replace, I got sine to be 3/5, so it's 3/5 squared plus cosine squared equals 1. Guys, that's 9/25. Let's just do the math real quickly. Cosine squared is equal to, move that 9/25 over, my goodness, I think 16/25 again. I think I saw that earlier. That's true? Let's do the math. Take a square root. Looks like cosine might be, let's see if it is going to be 4/5. I think. Now, do I have enough down to put 4/5 in, David? If I put 4/5 in right here, by the way, if it were negative, and you may be assuming it's negative, when you square it, it still becomes positive. So it makes no difference whether it's plus or minus 4/5, that'd be squared. Then you got this, Mr. Park. I'll ask you to help me out here in a second. Guys, final answer, 16/25 subtract 9/25. Where does 16 subtract 9? 7. Don't scare me. Is that 7? Is this that 7, guys? 16 subtract 9? And there's your final answer. That's what they wanted up here. Now, before I leave it, and I'm gonna have Park check it for me, if this has been missing, you would do the same thing I'm doing right here, except you don't have to worry about a formula. It's a little bit easier. But they placed the 2 out front, I had to use a double angle formula. Okay, Park. Guy, would you find out what inverse sine 3/5 is first? What's the size of that angle? Inverse sine 3/5.
36.8.
36.8. Now, would you do me a quick favor to double that?
73.6.
73 point, how much?
6.
6. Now, would you find cosine of that? And tell me what it's close to.
0.28.
0.28. Now, we got an answer to this. Now, would you see what 7 divided by 25 is?
0.28.
It checks. That's all I'm doing for a recap. Got a few new items to point out here right quickly. I saw looks from the class. Wow. This test professor, if I'm not careful, could, at the same time, they could bump me on up. And I've got a few students right on the edge. They could either go up or it could go down. We're hoping it goes up. That's why he gave you those 4 points, and I'm gonna give you 4 points also to help you cover yourself some. Marco, quick.
On the first part, since we're given tan data equals 4/3, for the tan double data, can we just double the 4/3?
No, she gave me away, I didn't do it. You're gonna find tan double theta, and you do not want another formula, even though the textbook gives you another formula for tan double theta. Just think of it as sine double theta over cosine double theta. Sine with cosine is tan. Now you're not gonna double this.
Okay.
You gonna make that 8/3? No. You can't double that. Okay, guys? With me? Woo. Okay. Now, I noticed here, someone remind me, the handout, I gave 2 handouts on Wednesday of last week. One was a review for the test.
Yeah.
Another, I think, had material, something like I'm talking about here, maybe on there. David, is that true, like formulas? Was there one sheet with lots of formulas listed?
Yes.
Let me see, or it may have been, on one side here. Okay, if we did, this is chapter 7 here. was there one sheet that somehow was passed out to you maybe earlier had formulas on it? Okay, this has no formulas listed for you. Okay, there's one that's supposed to have some formulas listed for you, no? That's sine A plus B, cosine A plus B. I thought I gave it to you, forgot where it was. There you go. Yeah, it's on back of that. Okay, it's like this. This is law of sines, law of cosines, that's a different one also. That's chapter 7. Chapter 6 was the handout that had the formula, cosine A plus B, sine A plus B. It is. Here you go, finally. I thought I passed that out. Looks like this. Looks like this. As your sine A plus B and so forth and so on. Now, Sarah, do me a quick favor, if you can. Would you look on that and tell the class, did I have, besides A plus B and A minus B, the formulas you gotta know, did I have also the double angle formulas maybe on the back?
Yeah, on the back is the double angle formulas for sine and sine squared theta and cosine squared theta.
Beautiful. Did I have one for a half angle?
No.
No. And that one flows down chapter, I don't think I have one. Yeah, maybe I didn't pay.
Yeah.
I don't have one on that particular
There's
handout.
no back paper.
Okay, so double angles, A plus B, I have all those formulas on there for you to refer to. Guys, to close it down, here we go. I'm calling this part D, I guess. If you're asked to find, and I'm gonna get some input from you first before I jump into it. Something like this. All of a sudden, you're taking the test, you say, oh my goodness, professor, you've asked me to find this. Find sine of pi over 8. And pi over 8 is not one of those on the unit circle. So you're seeing that thinking, I don't have the device that Park uses, so I can't do it, Professor. So you're gonna think in terms of, there must be a formula he's after, or the textbook's after for you to answer that. First, it's a little odd. Does anyone know in degrees right quickly what pi over 8 really is as an angle? I know it looks odd as pi over 8, but do you have an idea of what size is it really? Let's say in degrees, if you convert it.
10 degrees?
No? I love it. 22 and a half degrees. Now how on earth are we gonna find 22 and a half degrees using sine A plus B? If it come out to be 75 degrees, that would be 45 plus 30. And you could easily do a sine of 45 plus 30 and use your sine A plus B formula. No, this is not 75. What he gave me 22 and a half. Was it 22 and a half? 22 and a half. Can you step back and look at it, guys? Therefore, to close down chapter 6, yeah, they do. They give you half angle formulas. As if you don't have enough. Now, I'm gonna point out this for you, and then apply it, and then I'll have all my formulas and I'll feel good about this. Guys, first one, if you're asked to find sine of half of an angle, as I heard him say a half was involved, 22 and a half. First, can anyone tell me, before I tell you what the formula is, what on that unit circle would you be taking half of to begin with to get 22 and a half? 45. Which now takes me back to the unit circle, pi over 4. So you can quickly say, hold on, Professor, at least I know this. You're talking about sine of 1/2 of, let me write this in radians, 45 degrees, pi over 4. And I think when we see this, that definitely sees pi over 8. I just rewrote pi over 8 like that. It's half of 45. I wish you could just go back and say, okay, let me go back to one of my notes and just take half of 45 and Professor, I got it. No, it's gonna require a formula. Now your textbook shows the formulas to be this one. For sine, it looks like this. They have plus, minus, so you gotta be careful of the sign. has a square root around it. And the one I'm looking for here for sine looks like this. 1 subtract cosine theta all over 2. All underneath that square root. If you want a cosine, I'll do cosine for you. Merely a formula, I did not derive it for you. Just give the formula to you. If you need a cosine, it's plus minus for a half angle. Much the same, except it's 1 plus cosine theta over 2. Closing all this down. Definitely gonna close all this down. It's definitely let me close down here. Now, guys, I'm gonna apply this. Now, by the way, he's already given me, he says, Professor, pi over 8 is 22.5 degrees. Thank goodness that's in quadrant 1. Everything's positive in quadrant 1.
Yeah.
So all I'm worried about is, I could erase that negative sign. It's positive. I just want sine 1/2 theta. Now, guys, if I replace in the formula, you got a new formula, it's gonna be square root of 1 subtract cosine. Cosine of what? What's acting as theta? Pi over 4. Is pi over 4 what I'm looking for theta here? And it's all over 2. Right there is what you're looking for in your formula. Right here. Now, pi over 4 can be dealt with without a calculator. It's going to look strange. This is going to be square root of 1 subtract. Guys, that comes up to be cosine pi over 4. We all know what cosine pi over 4 is. It's what? Radical 2 over 2. No problem. All over 2. Now, you talk about cleaning up? The rest of this is just cleaning up. On top, common denominator, number 2, make it look like this. That's the top part, and that's still over 2. Which now looks like this. Square root of 2 minus radical 2 all over 4. Now, can I clean that up just a little further? Yeah, I think there's the square root of 4 is nice. The top is not nice. So I'm going to leave it like this. All over what? 2. There's your answer. If you were asked, and they will ask you in math 7, math 8, what's the sine of pi over 8? Now, I can have Park do all the estimations for me and check it, make sure we are okay. I feel good about this. Strange looking answer, a square root within a square root. And if they ask you for cosine, same thing, except now you're going to use this formula to work with. Guys, how's that look? Mr. Parker, you didn't check this one out for me, did you? Did you check it yet?
For what?
Just right here. Do me a favor. Find sine of, what was it? A sine of 22.5 degrees. Tell me what that is first. The sine of 22.5.
0.38.
0.38?
Yeah.
Okay, now, hang on. We got this crazy answer. Now do me a favor, can you find out what all that is?
Mm-hmm.
I hope it's close to 0.38.
That's 0.38.
It does agree. It agrees, right?
Yeah.
Okay, so we're good. That's the answer. Now for me, chapter 6, I spent a little bit more time than what I thought it was going to do on this recap. It's done. It's done. Samantha, I saw your hand go up.
Yeah, do you mind just explaining what the exact formula is for the half angle?
Okay, now I just gave it to you. I didn't show you where it came from.
So it's what exact? It's 1 minus cosine
Yeah,
theta?
1 minus cosine theta, and theta in this case was 45 degrees.
Got it. And then for cosine, it would be 1 plus cosine.
That's the only difference. So if
Okay.
you know one, you'll know the other. And I just gave those to you. I did not show you a derivation where they came from. That's part of the formula, that's not me,
Oh,
that's the formula.
so the difference is.
Yeah, area of a circle is, what is the area of a circle, pi r squared? Right. Ah, okay.
And how do you know it's positive or negative again?
Yeah, you gotta find out what, first it says, pi over 8, where is that angle located? That's 22.5 degrees, that's in quadrant 1. So this right here will tell you the location. And then that tells you what sign to use. So pi over 8, 22.5 is in quadrant 1. How's that looking? Okay, don't get your instructor worried. After all this hard work you guys have done, I've been bragging on you so much. And other instructors that have even heard about you. Some of the instructors I didn't even know you was teaching this. Ramsey, you have a good student in math too? No, why? I don't have any good students in math too. Because they want you. I'm not gonna tell you your names. You know, they are, we need some good students. They were looking for me for good students. So they heard about you. They know you. Now, chapter 7. Please remind me from last week, you did chapter 7, close down, so I'm moving to chapter 11. Chapter 7, did we do a right triangle or is like opposite of right hypotenuse, adjacent right hypotenuse? All that business?
Yeah, we did.
And they just give me a triangle and ask you to solve it, find missing parts. Chapter 7, guys, basically, that's it. It's a triangle, they ask you to find the missing parts. There's a few things I need to say, though, to close down officially, chapter 7. Now, would it be nice if I listed all the formulas for you on the test?
Yes.
Or give you a formula sheet? Wouldn't that be nice? Is it gonna happen? No. No. You're gonna know all the identities, all the formulas. And you will appreciate that after you move on into math 7. Okay, guys, close out chapter 7. I've done this. Close it down. All it comes down to, a very short chapter, is solve a triangle. Call it part 2, I guess. That's basically this. Now watch carefully. First, we'll put these triangles in categories. Solving triangles, if it's this type of a triangle, we flushed out. They ask me to find the missing parts of the triangle and it's included, or there's a right angle included, it's a right triangle. You can use, Lisa, you can use from last week, the basic formulas were sine theta can now be represented as, I know it's y over r, but I think we extended that out into what? Opposite of hypotenuse. So I'll just abbreviate to save you some time here. Cosine, if it's a right triangle, is x over r, no problem. Does anyone recall what the x over r represented? Adjacent. Absolutely. And I think the last one I did for you guys was tangent. That's y over x, of course. That's all it is, opposite over adjacent. Okay, those are the 3 basic ones. Now, you walk in next Monday, and you see a triangle, like I had here, and they ask you to solve it. You say, Professor, please, no issue on this. And my triangle in this case looks like this. We are a right triangle. Let's make use of this. Yes. Yes. We have a right angle here, guys. We'll label a triangle, capital letters, like this. And since I use those capital letters, we'll use lowercase letters opposite those capital letters. So what you see, c squared is equal to a squared plus b squared, the Pythagorean theorem comes out. And I've marked, on this first example, let's see what I do here. Yes, side A has a length of 2. And looks like also, we're going to try this, I changed it a little bit here, side B has a length of 8. Now that's given. They want you to find the missing parts, if we can. Now what's missing? Side C is missing. Angles, angle A is missing. Angle B is missing. Now, does anyone have an idea with what I gave you? Is there any way to find side C, lowercase c, or angle A, or angle B? I don't care which one you find first. Go for it.
Like a squared plus b squared.
Absolutely. You can use Pythagorean theorem. C squared is equal to a squared plus b squared. No problem. Pythagorean theorem, c squared is equal to a was given to me as 2, so that's 2 squared. Plus, in this case, 8 squared. So we're going to end up with 4 plus, help me out here guys, 64? I guess it's 68. I guess I did that quickly. And take a square root. Of course, square root 68 is not perfect. And we'll simplify into, I think it's 2 radical 17. Let me break it down. So there's the length of side C. That's done. If I have no mistake, watch out for the mistakes I could make. Now, angle A and angle B is missing. Any ideas how to find angle A or angle B? Let me go and put this one that we just found here. This is 2 radical 17. That one's out of the way. Does anyone have an idea how to find either angle A or angle B? Marco. Okay, you want to use, if we're looking at angle A here, you want to use opposite of hypotenuse?
Yeah.
Now, opposite was given to me as, that's A. Hypotenuse is what, 2 radical 17? Is that true? Could he use opposite of hypotenuse? Or on the side here, he wants to use this. He says, Professor, take sine of angle A, opposite of hypotenuse, here it is right here. Opposite angle A is side A, which is 2, over the hypotenuse, and I guess hypotenuse came out to be that 2 radical 17, yes or no? Marco, is that what you had in mind? Is it? By the way, guys, was it A2 here? And B was given to me as 8. Mark those. Opposite of hypotenuse, I do see, like he says, 2 over the hypotenuse. Yes or no? Simplify this, I can't do much, I can cancel the 2's out. That's 1 over radical 17. That's going to be radical 17 over 17. Now, someone in class tell me, sine A is equal to that. I'm looking for A. What would you have to do to find A? We got sine A, if all that's correct, that Marco helped me out with. What's A? How are you going to find A? The size of A, is it 32 degrees? Is it 42 degrees? How would you finish? What do you think would have to be done here? To come up with the size of angle A if all this is correct. What's an idea? In other words, I'm looking for this. I'm going A. I know sine A. I want A.
B plus C.
Put them out.
Tangents.
Go again?
Tangents.
No. And if I asked Park to do it for me, he'd have to do the same thing. Samantha.
Can you do, if sine of A equals, so can you do sine, B plus sine C?
I know what what you guys want to do, you want to reach out and try those identities and so forth. Not in this particular case here. Something would have to be done, and Bart would have had to finish this thing up for me. What would you have to do?
Isn't it like y?
Yeah, hang on.
Is that like y divided by r equals the sine?
Sort of. Let me give you an example. Suppose you saw this. Sine A is equal to 1/2. So we'll get back to my problem. What's A? What A will have you seen out there in the unit circle? Whose sine, which is y, whose sine is 1/2? 5/6. You say, Professor, it's 30 degrees. That angle is 30 degrees. David? Sort of the same thing here. In other words, you're going to find here, but I've never seen this on the unit circle. So the best I can say here is if you want it, and have to have Park to finish it up for me, A can be found if you do this. I'm going to put the approximate symbol here. You have to do an inverse on that number, like that, if you want the value. Park, can you do that real quickly for me? Take the inverse sine of radical 17 over 17. Don't limit too much here on this. And tell me what size angle is angle A.
It's 14.
14 degrees?
Yeah.
I'll take 14. I have no clue myself. Now, could I give you numbers like this so aiding on the test? Of course not. I'd have to stick with numbers that make them out to be a 1/2 or a radical 3 over 2, something you recognize from the unit circle. But on something like this, you have to turn to an inverse, say, oh, I've got to do an inverse to get A itself. Now, by the way, after I find this one, could I find, what else was, this is 14 point, oh, close to 14 degrees. Now guys, can someone tell me quickly, if you had to, how could you find B? Yeah, 90 subtract that. All three angles should sum up to 180, so 90 subtract that leaves me, help me out here guys, 76, I think. Is that true?
So how could we solve this without a calculator?
Now you not, that's what I'm saying. I cannot, unless I gave numbers to you like a 1/2, a radical 3 over 2, some number you recognize. Have to make sure those numbers are given to you that you recognize. You're not gonna get a radical 17 on the test, you can't deal with it. Okay guys, so it's a triangle. Now, let's do this. Part B. Just bear with me, closing all this down. I brought in, let's see if I did, doing a good job on this, trying to get students to think here on a Monday. Okay, they have in the textbook, and I gotta do this. They're saying now have students look at a triangle. Guys, we'll have mine look like this. Chapter 7. Let's label this as ABC, capital letters, lowercase letters, opposite. Now watch carefully. Oh, this thing is beautiful. Now, David will ask you besides what we're doing here, opposite of hypotenuse, adjacent of hypotenuse, all those. They're saying now have students to now consider a triangle and now find, express the best you can. Find the area of this triangle. Find the area of triangle ABC. If I walk across the street, we're still in school over there. And I see a kid and ask me, find the area of a triangle for me. What do you think most students will quickly tell me if you're asked to find the area of a triangle? Middle school, elementary school,
1/2,
area is equal to 1/2.
base times height.
Thank you, stop right there. That's what students would say. Professor, take 1/2 base times height. No problem. Now, if I look at my triangle, the base is side C. I got the base, what's missing? The height. I got to draw the height, perpendicular. So we'll have this as a perpendicular to represent the height of the triangle. We'll make a right angle. Of course, that's going to represent now the height. And watch carefully, because I'm deriving this one of all the things I've done today. I'm deriving something here. Now, I need 1/2 base times height. Now, I need some input, here we go, on the side, trying to find the area. I use this formula, middle school, 1/2. Base, my base is C. There it is. Height is H. Is that true? That's the area. Now, though, on the side here, I'll come back to this. On the side here, since I dropped that perpendicular, do I now have actually two right triangles that I can somehow make a tie in this business? Because now, with that perpendicular, I have two right triangles. Suppose I go to the right triangle on the left, this one, and for a reason, ask you to express this. What's the sine of angle A? Right here's angle A in the right triangle on the left, and I know sine's definition is opposite of a hypotenuse. Anyone tell me what the opposite of a hypotenuse would look like, the way that triangle right here, this triangle, shade in,
H over B.
will be H over B. Thank you. Or better yet, just multiply this out. B sine A is equal to H. I just multiply both sides by B. Now, is there another right triangle? So a student may say, wait, Professor, there's another one that you could look at, right here, on the right. And then that one, try to express sine of angle B. Let's try that, guys, sine angle B. Now, can anyone tell me, on the other right triangle, still opposite of a hypotenuse, what would the opposite of a hypotenuse look like on this one? H over A. Better yet, write this like this for a reason. No problem. Now, hang on. Now, can you tell me what am I going to do? We stop with the area formula. Here's the area formula. We want this. We want to express the area. This is what I'm after. I brought this on the side for a reason. Please tell me, could I go back to this? I better go over here on the side where I've got space. 1/2 C. Do I have a replacement for H? Could I replace H by something here?
Yeah.
Right here, one replacement, B sine A. That's H. So I put it right here. No problem. Another student may say, wait, Professor, you could also do this, 1/2 C over there. Was there another replacement for H if I want to use it, besides the one I used, A sine B? Now, hang on. And so happens there's a third one, which I have not in my sketch shown you how it's going to work. I think we're going to guess what it's going to be. But first, before I show you what the third one is, let's take a look at what this says. You find the area of a triangle, any triangle, right? Non-right, this was a non-right triangle here. By taking 1/2 of the product of two sides, B and C, and then times the sine of A. Notice where A is located in reference to B and C. Where is A located? Is it located between? Yeah. Is angle A caught between? They call it included. Is it included between B and C? The other way to find the area, you get the same answer. You can say 1/2 these two sides, A and C, times the sine of the included angle here is B. If you're using A and C, you could use that there. Now, can someone tell me the last case that I could use if I wish to find the area? Another 1/2 something. Lisa, I'll put the 1/2 in there for you. Now, which two sides would you like to use? I've already used BC and AC. What's left?
A and B.
A and B.
To get this.
Okay, A and B. And she uses A and B. She's going to take, here we go. Hang on, not A and B. We'll take 1/2 of, here we go, guys. times H, so you wanna say A times B. Okay, 1/2 A times B. And if you chose those two sides, tell the class what sine of what angle are you using here? And the angle caught between is what, C? So guys, I showed a short derivation to define the area of a triangle, any triangle. You take 1/2 of the product of any two sides you wish, times the sine of the included angle. Okay, questions here shortly. There's 3 of them there. I've shown you a couple where they came from. Now if I clean this up, that's where you find the area. Now if I clean this up, I've got to be careful the way I'm going to do this. This is how to find the area. Those kids across the street just know 1/2 based on height. Now you know a little extension. You can use any 3 of these to find the area. Now if I clean that up, I'm going to multiply everything by 2, guys. If I multiply everything by 2, I'm going to write this as CB or BC, sine A, multiplied by 2. Here, AC, sine B. And here, AB, sine C. Let's multiply everything by 2, try to clean it up. Now I think as soon as I do one more step, some students who have had experience with this trick somewhere else may recognize what's going to happen. I'm going now to divide this result by this expression, A, B, C, all the way across. Now what's going to happen? Marco, I divide by ABC, try to show you a little derivation. If I do, you say, wait, Professor, if you do, the B's will cancel here, and the C's will cancel. Now what are you left with? Sine angle A over lowercase a. Boy, that's a good match. A's and A. My middle one here, A's cancel, C's cancel. You're left with sine angle B over B. No problem. Last one, A's cancel, B's cancel. You're going to end up with sine angle C over C. Now guys, this is not the area. I took the area formula. The area formula's up there. But I did it, took the area formula, played with it, and came up with something else. Does anyone recognize that? Who's had maybe a experience with some trig back in the day? They give a name to it. I derived it for you. They call it law of sines. Law of sines. Beautiful. Now, here we go. One more triangle, then we're going to take a break here. My next triangle, I'm going to find some missing parts on another triangle here. If I do the law of sines, and I know most students would think, Professor, is there a law of cosines? Now, there is. Now, think about one of those handouts. Now, the law of sines, if I brought in this to close this down, beautiful. There goes. Let's hope we do not mess this up. I do not mess it up. Maybe we're not gonna mess this up. Nice. Okay, I got triangle ABC on the side here. Guys, make sure you see it. Looks like this. Label that like this. And I gave some numbers to work with on this one. I brought in the numbers here. Angle A is 45 degrees, given to me. Angle B is 60 degrees. And side A, over here, has a length of 40. Hope you find this apart. Okay, ready, brothers, slow me down, chapter 6. found the missing part. David, can you tell the class what's missing on this triangle?
Angle C,
C's
side
missing, hang
B,
on now, capital C's missing. What else missing?
side B and side
Side
C.
C's down here, lowercase c's missing. And
B.
B is missing. In a way, Professor, that's so clever of you. You want to sort of close down before we take a break, we're back to this. I'm gonna find the hypotenuse and put the opposite of hypotenuse as an adjacent of hypotenuse. What has Ramsey done here at the end that I cannot go back there? I can't use opposite of hypotenuse on that triangle. Why? I can use adjacent of hypotenuse. It's not a right triangle. Your textbook uses the word oblique. This triangle is an oblique or non-right triangle. I can't use that. I wish I could. Can't use it. Now, guys, to do it, angle C is missing. Now, angle C I can find quickly though. Yeah, because we got 45 plus 60, that's what, 105?
75.
Yeah, all the angles should add up to what, 180? So she's telling me right quickly, Professor, the angle at the top there must be 75 degrees. That's no problem. I think you guys would agree with her. Now, David, you told me also, Professor, side C is missing, side B is missing, and I can't use that over there. Now, what can I do? That's where I turn to this. Can we do a match on this triangle using this conclusion here? It's called law of sines. A sine A over A. Let's see if I have enough here. Why not? On the side here, guys, that would be in this case sine 45 degrees over A was given to me as 4. Now, can I do a match on another one? Or did I give you enough to work with? Sine 60, hang on now, sine 60 over side B. I have enough now to cross multiply and find side B. And notice I give you an angle that you can work with. I don't have to turn the part this time. I give you an angle you can work with, 60 degrees. So if I do a quick cross multiplication, let me do a quick cross multiplication and show you what it is here. B is going to be equal to, right quickly, 4 sine 60 degrees all over sine 45 degrees. Just step back and look at it, make sure I did not make a mistake before I stop. That's just solved. Now, do you recognize those angles? I didn't give you something like 17 degrees or 12 degrees. No, this you recognize. Guys, this becomes now on the side here, this is 4. Sine of 60. I don't know whether students remember what's sine of 60. Radical 3 over 2. Thank you. In a circle. Down here, sine of 45. Radical 2 over 2. I can do that without a calculator. Clean this up. I'm going to cancel 2 into 4 and make that a 2. I know it's going to look like a straight answer. So it's 2 radical 3 on top there. Still over this. It's getting strange just to clean up business. But it looks like that. Anyone tell me at this point what else could I do? You cleaned up a little further? Yes.
Multiply 2 radical 3 by this.
Okay, so you're going to end up with 4 radical 3. Beautiful, I heard what you said. Over radical 2. I think you told me that. Yeah. And before I leave that, don't leave it like that. What should I do? Rationalize. Multiply by radical 2. Radical 2. Hang on, I'm not finish it. But right now it's going to be 4 radical 6. All over 2. And then cancel 2 into 4. Are you kidding? All that work. If we have no mistake in all this work, came out to be 2 radical 6. Does anyone see a mistake? 2 radical 6. Now guys, that goes, which one was that? Side B? Oh, that's side, oh, it was B. So it's 2 radical 6. Now, we're gonna run out of time here. I'm going to chapter 11. One of my favorites after the break. Let's one more side missing. Can anyone tell me? You may not do it. How would you find now side C? And we have now, this one is this strange number. The side C is the only thing missing now. Does anyone have an idea? Marco?
You do sine B over B equals.
Hang it up. You want sine B over B? You want that again? Or would you like to stick with, because I may have made a mistake here. Here's the problem. You can do that. But I may have made a mistake finding B. So won't you stick with what was given?
Use the given,
Okay, sine what, 45?
sine 45 over 4.
Hang on that, Lisa. Good suggestion, good suggestion. Equal to
Sine C,
75?
75 over C.
There you go. And then do your cross multiplication, like I did on this one. Go through all the business there and find it. Now, here's where we're gonna close down. You can do the cross multiplication and stop it, find it. Can anyone tell me the issue here on this one? I see hands going up, that's why I love this class. This one worked out so nicely, I gave you English to work with. Right? You said, Professor, that's nice. 45? I need no calculator. 60, no calculator. All of a sudden, if we have this one correct, I've got 75 degrees. I don't think I've ever seen 75 on the unit circle. It's there, but it's not one of those we ask you to know.
But can we add?
Sarah.
What were you?
Hold on. Sarah.
You're gonna have to, do sine, we'll find like the difference of two signs.
Or,
So you have to do like sine also.
like this, I think.
Yeah.
Look at this.
The difference or you add.
Is 45 plus 30, 75? And David, you talking about a challenge problem, that'd be an extra credit type. Now, you know what you have to do now? You got to now turn to sine A plus B formula. Another formula. Is that in the formula right now of A plus B? I turn to sine A plus B and do that. Good luck. And then bring it back in, and you have this triangle completely done. How do you use this word for the questions, Marco? Again, these triangles, guys, are non-right, no right angles. Your textbook uses this word just in case you run into it. It's an oblique triangle, a non-right triangle, oblique. What was that question that you had way back?
Or how do you find like sine of C? Is not like the same as sine of A?
We have here.
Yeah.
Oh, I got you. I dropped my perpendicular. I got you. From here to here. I could drop the perpendicular from here to here.
Oh, and then you,
And thank you. You said it exactly right there.
so but right now there's no sine of C.
Ah,
Okay.
but then I asked, just based on what couple that I did do, could someone guess as, and I think maybe it's me, guess as what it would be. Now I could drop it perpendicular the other way. And then that would open up angle C. Samantha, yeah, chapter 7's done.
You can do, I mean, it's like sine A plus B, so you can do,
Oh, yeah, right here, if you finish it up, Samantha, you just do sine A plus B, which I think is what, sine A cosine B.
sine A cosine B
Plus
cosine
cosine A sine B, turn around. You have to use that, which is a problem within itself. And you have to bring that back in if you find it, and put it, where on earth was it, where you had to find it, up here. And then you do your cross multiplication, you get substitution. Okay, chapter 7's done. Chapter 11, I don't think I've mentioned chapter 11 at all. It's a completely different view of math altogether. Wait till you see what's going on there. I like it myself, because I think it's more like you keep on aid and comparing everything to the polynomials. Professor, let's go back to polynomials. You know, types of problems with polynomials. Not triangles, Professor. Let's do polynomials. This chapter 11 coming up is somewhat, they're not polynomials, but sort of remind you of what we did back then. Guys, any concerns here? Now, I was But again, I'm expecting out of this class, telling one of my colleagues, I'm expecting, and probably some of those classes, I'm being very honest with you, the math 2 classes are down to 4 students. 4. Some are like 10, it's a good sized class. And I still have 26. So you guys have done it. You have done it. Because that 4 o'clock session we have, and most of my students come in at 4 o'clock and see what's going on. And the work we put in, it's working out for us. Okay, so I expect a couple, hopefully more than a couple, to get it perfect. I'd love to see that. Mr. Parker, it's been a long time, hasn't it?
Yeah.
Since we've seen perfect?
Mhm.
Okay. Mr. Parker,
Hmm.
come up here just a second. This
Oh.
guy has been working